So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we are basically doing revision before going for the application. So, why we are doing revision? Because you have to know how we can predict or the earthquake hazard or earthquake. So, that involves like the understanding of whatever we studied so far. So, as we said that, okay, so the earthquake hazard creating lot of casualties as well as the economic loss. So, all those things. So, the one of the way to reduce is actually to understand how the earthquakes are happening, how the wave propagation happens, all those things, understanding the physics. So, the other way is to forecast, okay, so or to predict so the earthquake and earthquake hazard. So, as on today the science it is very clear that the earthquake cannot be predicted. So, the only way is to basically to take care of the reduce and minimize the impact of the earthquake is basically we have to forecast very accurately. That forecasting involves understanding of the earthquake. So, that is what we studied so far. So, still we are want to make sure that whatever we studied you understand properly. So, we are recapping all the subject whatever we studied on different topic. So, last class we have discussed on the wave propagation. Okay. So, it is very clear from the wave propagation that so the wave travel controlled by the medium what it travels, basically the stiffness, okay, and the thickness of the medium. So, the another parameter which controls the wave propagation actually the wave speed and wave character. Okay. So, the some wave will reach first, some wave will reach later kind of things. So, when you understand the earthquake, so wave propagation wave. So, the way of recording the earthquake is basically you have to try to have the instrument, okay, which is called as a seismic instrument, seismometer or seismoscope, where you can try to record the waves which are produced by the earthquake. So, then you can quantify the earthquake. Okay. So, today a couple of lectures, okay, so whatever we are going to see is actually the portion which is covered after the wave characteristics. So, if you look at so this earthquake damages since historic times the human settlement or human being are try to escape from the earthquake. So, we have been seen that in olden days people actually had a seismoscope which is called as a Chinese seismoscope. So, in the age of 1832 AD, so which is basically reassembles a big wine jar. Okay. So, this is the wine jar which reassembles the seismoscope. So, in this actually there was a 8 dragon, that is what we have seen, the 8 dragons are there. So, each dragon hold a ball. Okay. So, this ball it holds. So, when this ball hold there is a 8 toed down there. So, this instrument, okay, so it is basically a metallic kind of instrument. So, which shows anywhere in the nearby area about close to 400 miles. Okay. So, if any seismic events are taking place, this dragon will drop a ball on particular that direction. Okay. So, that is how it is been. So, you can see that this seismoscope more or less tried to predict a earthquake. Okay. So, only thing the time what it predicts, okay, may be the lower when considering the the earthquake the time period and all those things. So, generally the earthquakes are happening anywhere 0 to 400 miles. So, this can detect. So, immediately drop a ball. So, I may be thinking that, okay, I am thinking that this may be invented purposefully in China. Those days Chinese called Japan, China and all those regions. So, there was a lot of tsunami. Okay. So, all the earthquakes which happened in the tsunami happened in the sea used to cause a tsunami. So, these people might have used this system, okay, to know that the earthquake has happened in the sea, as we have seen that even though the seismic wave reaches first, but the tsunami waves reaches very late. Okay. Sometime it has 1 hour, 2 hour, depends upon the location. As you know that the Sumatra earthquake 2004, the tsunami reached about after 2.5 hours to the Chennai and east coast. Okay. So, which indicates that you have sufficient time to move the people. So, only you cannot get the waveform may reach very fast as the waves are traveling with the speed up like so the P wave is actually travels close to like 5-7 kilometer per hour. Okay, so the S wave travels 3-4 kilometer per hour. So, but the tsunami wave travels very less speed. Okay, so when you look at the tsunami what we discussed during the earthquake hazard, it travels very less speed. So, generally it takes very long time to reach the particular place. So, this seismoscope, okay, they might be invented or to predict earthquake. Okay, but this was the origin for the seismic research on seismic instrumentation part. So, many scientists try to understand how it is working, many British scientists try to understand how it is working. So, it is not possible very clearly to find out how it is working. So, basically they figure it out that it is working a concept of a simple pendulum. Okay, so that pendulum basically so connected to the ground. So, it stays horizontal, okay, or stationary position. One is inertia mass. Okay, so when there is no movement, when there is a movement, so accordingly the pendulum will move. So, the relative moment will be used to know what is the size of earthquake. So, depends upon the frequency of the waves. So, the mass, okay, and the damping can be vary to get a reliable this one. So, this is how they come up with the conclusion that the pendulum kind of concept might be used in seismic, but it may be inverted as we are seeing that ball was dropping from top of the jar. Okay, but still they have speculated that this may be true, may not be true, something like that. So, the simplest the modern seismogram basically. So, the consist of the mass and spring constant and damping. Okay, so, then these are all housed in the system which is connected to the drum where it can draw a whatever movement it is happening. So, when the ground moves, there is no ground movement, mass and then the stiffness and the damping is kept such that it does not create any zigzag motion. Okay, it creates some kind of straight line motion kind of things. So, when the ground moves, the relative movement, okay, so basically taking into place that create a zigzag waveform whatever it happens accordingly the ground moves. So, due to the P wave, S wave and surface wave, that portion was actually recorded in the drum. Okay, so, that is how the simplest form of seismogram has been there. So, depends upon the direction of the recording, you can have the single sensor and multiple sensor seismic instrument. So, basically the any seismic instrument should consist of the suspended mass hanging from the support that attached to the ground and inertia to keep the suspended mass stationary while ground moves below it and the movement of the recorded rotating drum or magnetic tape. So, basically the system which sense the vibration and then reflect that vibration in the form of waveform and then that waveform writing, okay, the drum or magnetic tape or digital record is another component. So, apart from this you should also need to have the time system so that you will know when and where the waves are arrived. Okay. That system also integrated. So, this is a typical old seismogram, you can see with paper. This is basically magnetic tape, the zoomed portion of that paper writing kind of things. So, this is a very common when the olden days seismometer was involved. They had analog system where it draws a signal in that. So, the simple way of working this actually can be understood from the building your own seismogram concept. So, where there is a mass, okay, so which is suspended here. So, when the ground is this one, this mass does not move, when the ground vibrates basically this moves back and forth, that create a this one. So, this is a simple wooden, okay, so homemade seismogram you can make and you can shake here, you can see this one. So, this related videos, okay, the seismogram explanation and then their discussion you can find plenty of videos and explanation in the YouTube. So, you can refer that and get enhanced your knowledge on this subject. So, the wave, okay, so the wave coming on the different frequencies. So, accordingly the seismic sensor which detects should also have a particular frequency of interest where which wave you are looking at. So, this is the typical frequencies generated by the different seismic source, okay, and then the corresponding. So, if you want to record a particular type of seismic waves which is created by the respective source, you should have the corresponding frequency capacity of the equipment. Okay, you can see that the earth tide vibrates into 10 to the power of -5 to 10 to the power of -4. So, the earth free oscillation earthquakes are 10 to the power of -4 to 10 to the power of -3, and then surface wave earthquake 10 to the power of -3 to 10 to the power of 2. So, then 10 to the power of -1 to the 10 to the power of -2 is the surface V wave and S wave with the earthquake -6, and earthquake -2 and 6 0.1 to 10, and then P and S wave the earthquake magnitude less than 2. So, you can understand that depends upon the what type of earthquake you want to record, you should have the respective the frequency in the selection or sensor should be installed in the seismometer what you are looking for. So, based on the sensor type, okay, the seismometer has been classified. So, based on the sensor type, the seismometer can be classified. One is the short period sensor where the instruments sensitive to the seismic wave that vibrate several times per second called as a short period seismogram, and used to record mostly on the local earthquake which is reporting within the few hundreds of kilometers like 100 kilometer, 200 kilometer, 300, those are all the local earthquake. So, these short period sensorograms are basically as magnifying the ground motion level 100,000 times, it depends upon the instrument, and show you the waveform which is occurring on the particular earthquake. So, the another sensor is long period sensor. Long period sensor basically respond to the lower frequency waves and are used to record distance, okay, events. So, most of the modern broadband seismograms perform the both short as well as the long period operation. So, based on this actually, okay, so the type of data it records, we can classify the instrument. One is the strong motion instrument or accelerogram or seismogram. So, the strong motion instrument basically records a strong vibration signal, basically acceleration of the ground motion. The G value record earthquake magnitude more than 3, and by post processing you can get velocity displacement and FFT spectrum can be obtained using this data. So, for example, the accelerogram always measures the acceleration value. So, the weak motion instrument or seismogram it records a velocity value. Okay, the both the value as we have seen that add a impact and requirement for the your engineering perspective. So, the another one is the broadband station. So, it records velocity, can record event occurring anywhere in the world, and range of time period instruments is 120 seconds. So, as I told you that these instruments are the modern today digital era, a lot of instruments are there. So, we can get this data recorded in this. So, this instrument when they initially developed, there is a analog recording system where all the records are made in some kind of paper roll or magnetic tape or some kind of recording where the analog sensors will be so moving like this. So, the analog sensors will be so moving like this in the given drum, okay, like this is the analog it will say. So, there will be drum, so okay, so which detects its portion of the data and record, that is analog. So, after electronic development in this is actually a typical. So, typical analog system, you can see this is the portable seismometer. So, which was used in the very early stage of the seismometer. So, this may be very few places you can find actually. As I told you that it is available in the IIT Roorkee. If you want to see this instrument, whenever next time if you go, you can go to the earthquake engineering department IIT Roorkee, you can see this instrument. So, then later due to the development in the recording system, magnetic tape has come, then digital record has come. So, nowadays most of the instruments are digital record. So, the analog and digital it has its own the advantage. Okay. So, for example, analog somebody can see physically data soon after the earthquake and understand how it is good. So the digital record, you need a computer, so where it has to be transformed to the computing facility, and that computer required a power. So in case if the earthquakes are occurring, there is no power, so then you cannot see the data until power comes. But the analog system, so you can see immediately. So these are all the advantages, but only thing, storing up data, processing and all those things, analog system, it is a problem. And a digital system, even you have the control over samples per second, okay, so how the time period changes, how you can pick up different waveform parameters. So all those things can be extracted in the digital system. So this when the digital system is come into picture, so the continuous recording, okay, raised the question, because the olden days the computer had and the very less storage facility, not like now. Now you can get several terabyte GB, okay, terabyte and gigabyte in the small pen drive, okay, the data are no, but the olden days where they used to worry and have unnecessary data storing in the instrument or computer. So they specify that sample rate, and then the how many bits each sample take, what is the data, how many data it produces, how many earthquake you can store using that. So then afterwards you have to replace the system which store the data, like storage device you should say. So there is this digital system brought into the concept of continuous versus triggered mode of data acquisition. So continuous means the data which is started when the instrument is started, it will keep on recording irrespective of that earth is occurring or not. The triggered system basically involves to make a provision, so it will monitor the vibration, but only record as per our we give instruction saying that only record the 0.0051 G, okay, at a particular place. Then it will see the record and the pre-event time you can give. So that is from this value whatever pre 10 minutes you record, and from this value end of this value record one more year, something like that you can basically make a provision. So that pre-event, post-event, all those things are easily controllable in the continuous versus trigger mode. So trigger modes are very effective to optimize the equipment storage capacity and get the required information from the storage, okay. So the samples per seconds is another important parameters apart from storage, which decides the size of the file. So the digital recording system, basically you can control a dynamic range, which is the ratio of the largest to smallest input signal system can measure without distortion. So these are all having the several application in the engineering seismology. Uses to store and simulate the data for the scientific approach, packing up the arrival time for phase on computer screen in the interactive manner by removing the cursor manually. So the phase are identified clearly in the digital system, where you can get a clear wavelet characters. These are all the wavelet characters you can see, okay. So these are all the wavelet characters. So the digital system has capacity to basically get your wavelet parameters. So which has like the duration, okay. So the true ground displacement pulse TW, the rise term TT, and also a signal movement, okay, by integrating the signal. So all those things, and then the envelope, the accurate measurement of the wave amplitude. So all those things are possible very accurately in the digital system when compared to analog system. So which gives a flexibility to map a source and estimate a ground motion parameters, okay. So time domain parameter, frequency domain parameter very accurately from the digital data. So that way the digital system basically requires a more advantage. Digital has a more advantage. It has been almost adopted throughout the world, most of the stations, okay. So the seismic movement, okay, so the seismic station, so seismic data, okay. So these are all basically interlinked, all of them reflected in the waveform, okay. So the recording data, interpreting the data are very important. So the place where these seismic instruments are kept is called as a seismic station, okay. If it is the one instrument kept at one place, that is called as a seismic station or seismic instrument location or something like that. So the seismic station consists of the seismometer, okay, by sensing the ground motion, clock to determine the time and record recorder to collecting a data. So, individual station can provide interesting information on occurrence of seismic events. Multiple stations are required to locate event accurately, determine their nature. So, the stations, seismic stations actually many seismic stations will be clubbed together and called as a seismic network. So, the seismic network basically has a 3 category: regional network, global network and seismic array. So, the regional network is basically, so the seismic instrument, number of instrument from 10 to a few hundreds will used deployed at a particular place to measure a regional earthquake data. Okay, that is the regional network. So, the global network is funded by the global funding agency. So, which like each country will have 1 or 2 this instrument which record earthquakes at anywhere in the world. Okay, so, it is anywhere in the world it will record, that recorded will data will be helpful to identify the earthquake in the universe. But as I told you that this is not simply not only record the data, these global networks are basically funded by the USGS and then other big organization, where they will also know that the other unusual vibrations created by the human activities. Okay, we have been discussing that during Abdul Kalam period. So, the Rajasthan Pokhran test was possible, and but it was detected because of the there is a global seismic network in the India. Okay, so with that we also seen a seismic array. So, seismic array try to understand the how the wave character changes in the small scale level. Okay, 50 meter, 100 meter, 20. That is why seismic array is used basically to understand amplification and liquefaction related studies. So, the India, okay, so these seismic instruments in India basically has been taken. Okay, so from the historic time, but the first seismic instrument was installed soon after the Shillong earthquake. So, during December 1, 1998. So, later this instrument keep updated and then keep modified. Okay, then it has been shifted in several places and all. So, overall we can see that before 1960 there is not much seismic instrumentation was deployed in India. So, which gives the idea that when you have the seismic instrument, okay, so history and knowledge, you can decide that whatever data somebody claimed that it is recorded is possible to record, not possible to record. There are several agencies we discussed that they maintain their own seismic network, the permanently or temporarily depends upon the application of the project and study of the interest. So, this is the typical Indian map, shows a different seismic station, okay, operated in the whole India by the Indian Meteorological Department. So, apart from this they also operate a dense regional network. Okay, so, in the Delhi region. Okay, so, then the other regions where northeast region where there is a frequent earthquakes are expected. So, this give you the brief idea about those things. So, this station in India, okay, whatever station we are talking in India has a different capacity. So, you can see that the right side India map marked with the circle indicates like how much magnitude you will get, how many times before they will tell you. So, that is the information you can get from here, you can see here. So, how the different stations are there, but there was a dense network in Nepal which is maintained by the IIT Roorkee, but now I am not very sure that network is operated or not. So, this seismic station, okay, as we said that it is from analog to digital since historic times. So, how these seismic stations will basically inform to the decision maker and political people and scientists about the earthquake. So, there is a time, okay, so which record. So, as olden days all the analog system 1 hour is to take. So, then the digital observation change 0.5, then the digital observation changed with 15 minutes, and finally, the today online whatever we are doing, whatever we are seeing watch and other things, where these are digital observatory kind of things where you can find the earthquake occurrence, okay, soon after 5 to 8 minutes time, which will give you the idea about how that particular earthquake was recorded, how the earthquakes are useful or not, what is the time of arrival or warning system given to the people. So, you can look at this group very the time period very carefully, prior to 1999 and then 99 to 2000, 2014 onwards. So this is the response time of that. Okay. So by looking at this, we can know that nowadays if you have the earthquake within 5 to 8 minutes, you will come to know what earthquakes occurred, where it is occurred, okay, which is not possible in the olden days. It will give you the earthquake size and then location. So, but the damage and other things one has to go physically and observe. So, with this basically we can close our class on seismic instrumentation, recapping this chapter. So, you might have understand that the recording a particular type of frequency wave are very important to know the size of the earthquake. Okay, that is why you have the different variety of equipment. You should choose appropriate equipment which is suitable to your region. For example, you are reaching only getting the high frequency waves. There is no frequency. There is no point in investing those kind of instrument and waste money. Okay. So, the people generally want to install a seismometer before they do the preliminary analysis and temporarily run a station for some time and find that the station information what they are giving is so useful for getting the earthquake data, okay, and used to get any earthquake parameters. So, this has been practiced, okay, so since the beginning. So, this instrumentation part a major role, okay, basically to sizing the earthquake. So, the wrong sizing will give the misconception as well as the lot of damage. So, with this I close this video. Thank you very much for watching. We will see you in the next class.